All right, welcome back to today's episode of solving these WAEC questions on electric circuits. These questions were extracted from Essential Physics textbook. Now let us go to question number 32. So we just solved this. Okay, we solved this before. Now let us solve this one. This question now says a wire. So let's zoom it up, okay? So let's zoom it so we can read clear. Look at the one we are solving now. Okay, so this is what we are solving. It says, look at here. It says a wire of length 100 centimeter and cross-sectional area 2.0 times 10 raised to the power minus 3 centimeters squared has a resistance of 0.1 ohm. Calculate its electrical conductivity. Good. So don't be confused. Let us go to the board. Let's quickly dissolve this question. If today is your first time of coming across this my page, please, I want you to consider liking and following this my page. You're going to be seeing a lot of content in a simplified form. Now, electrical conductivity of any given conductor or a material is noted as something like this. Then is equal to the reciprocal 1 all over the resistivity, okay? 1 all over the resistivity. So which means from this question, we need to calculate the resistivity of the material, which is the wire, okay? Now what is given to us there, don't forget, you must always list your parameters. The first thing that is given to us there is the length. And before you can calculate everything, you must define their SI unit. Look at the question now. The unit of length there is centimeter, but we are working with what? Meters, okay? So which means in our length, we are going to have 100 centimeter here. Now let's convert it to meter. I think you are dividing by 100. So what it will give to you will be 1 meter, okay? If you divide by 100, it will give us 1 meter, okay? That's 1 meter. That's for the length. Now let us go to the area. Area here says, according to the question, it says 2.0 times 10 raised to the power minus 3 centimeters square. I have 2.0 times 10 raised to the power minus 3 centimeters squared. So we also need to divide this one by 100 squared, because this one is working with what? Area. Okay. What you are going to have now, you divide by what? 100 square, because 100 centimeter make 1 meter. Divide this one by 100 square. And don't forget that 100 square means what? Look at it here. 100. Then squared. You square it, okay? If you square it, at the end of the day, you are going to have 10,000, okay? 10,000. How many zeros we have there? 4. And which means you can also express it to become 10 raised to the power 4. Because you are dividing, so you are dividing this one out by 10 raised to the power 4. So if you divide this one out by 10 raised to the power 4, so the exponent here, as you take it up, we have 2 times 10 raised to the power. It will now become minus 3 minus 4, because this one is going up, it turns to negative, okay? So at the end of the final answer here, area will be 2 times 10 raised to the power minus 7 meters squared. So take note of this. Don't forget, you must convert everything to its SI units. So we are given that the resistance there is 0.1 ohm, okay? Now let us go to our formula for calculating this resistivity. We need to calculate that. And remember that the resistivity of a material is equal to the area times the resistance all over the length. Now let us plug in these values. Where is our area? Our area is 2 times 10 raised to the power minus 7, okay? So let's put it there. Resistivity now is equal to 2 times 10 raised to the power minus 7. Then times the resistance. The resistance is 0.1. Now all over. What is the length? Length is, I think, that's 1. That's 1. Now what you do, this one here can be expressed. Look at this one here. So this here can be expressed as a standard form, so that at the end of the day, we can now have 2.0 0 times 10 raised to power minus 8. Okay, that's minus 8 ohm meter. So that is the formula for calculating the resistivity. So the unit of resistivity is what? Ohm meter. But this is not the answer we are required to get. Also, what we are required to get is the conductivity. So the conductivity is written like this. Okay, so it's like this. It will now give us 1 all over the resistivity. So which means we are taking the reciprocal of this, becomes 1 all over 2.0 times 10 raised to power minus 8. Now let's go. If you can use your calculator, straightforward, but if you don't want to make a mistake, simply just break it down to become 1 all over 2. We'll have that 1 over 2 here, distribute it, then times 1 all over 10 raised to power minus 8. Okay, so 1 all over 2 now gives us 0.5, then times 10. What we do, take this negative 1, because the reciprocal makes it to become what? 8. Okay, to become positive as you take it up, so it becomes positive. So now let us express it, everything. So that means the conductivity now will now give us, if you express this one, become 5 times 10 raised to power 8, because this one is a negative power, you take away 1. So finally, resistivity is equal to 5 times 10 raised to power 7. So now what is the units? It will now give us, because we are taking the reciprocal of what? Ohm meter. It will be per ohm, then also per meter. Okay, per ohm, per what? Meter. So this is our answer. I hope you find this lesson interesting. Please help us to share this post so we can reach out to other students who are writing WAEC. Bye.